Let's take a look at the questions on homework number 5. The first lesson on one-variable equations asks you to determine if there are no solutions, infinitely many solutions, or only one solution. Now, no solution and infinitely many solutions are special circumstances where the left side and the right side of an equation have matching variables. So if on my left side I had 5x, on my right side I had 5x, then I might have one of these special solutions. So let's take a look at what we've got here so far. If I distribute to clear these parentheses, I'm going to get negative 48x positive 48x, negative times negative is a positive, and negative 6 times 7 is negative 42. So 48x minus 42. Now on the other side of the equal sign, I'm going to get 35x and plus 42. So here's what you need to do. Look carefully at the coefficient of the variable. The variable term will tell you whether you have one of these special solutions. So if these variable terms were a perfect match, like 48x and 48x, then you'd have one of these special solutions. But unfortunately, these two variable terms are not a match. And when your variable terms do not match, that means you actually have a solution. One solution. The question is, what is it? So that's when you have to continue your math and figure out what it is. So I'm going to subtract 35x from both sides here. And because I don't have a lot of room on my screen, I'm also going to add 42 to both sides. That color's a little bit hard to see. And you'll notice that I have a cancellation, right? I have additive inverses on both sides, so I know that's fair. So 48 minus 35 is 13x. These 42's cancel out, these 35's cancel out, and 42 plus 42 is 84. So to isolate my variable x, I'm going to divide both sides by 13, and there's my answer. 84 over 13. Is it a crazy answer? Sure it is. But that's okay, because you can write a fraction as your solution. 84 over 13. You're going to type it right here in that box. 84 division bar or division sign 13. And submit your answer. Let's take a look at another question. Again, the first thing you need to do is always to clear the parentheses. So I'm going to distribute here on the left and get negative 16x. Distribute again and get plus 16. The right side of my equation needs nothing to be simplified. Now, before you go on and do any more math, look at your variable terms. Do they match? If they match, you have one of these special answers, either infinite solutions or no solutions. And how you determine which one of these you have, because we know we have one of these, because our variable terms are a match. We can decide whether we have infinite solutions or no solutions based on our constant terms. If the constant terms are a match, that's infinite solutions. If they were different, that would be no solutions. So again, matching variables and matching constants give us infinitely many solutions. Let's take a look at one more problem. First, you must distribute before you can look to see if you have any special solutions. So negative 24x and negative 8 times negative 2 is positive 16. The right side doesn't need any simplifying. And now it's time to look at our variable terms. Negative 24 negative 24, that's a match. So we have one of these answers. Infinite solutions or no solutions. How you decide is by looking at your constants. Are they a perfect match or are they different? Ours are different, so that means we have no solutions. Choose no solutions from the drop-down menu and submit your answer. All right, let's move on to the next section, which is asking for you to do the same thing, except it requires a bit more math. They want you to do a little bit more simplifying. So here, on the left side of our equation, we have some parentheses. So that means we need to distribute. But we don't distribute this number way over here. We distribute whatever is touching the parentheses. And we never combine these terms. So we're going to distribute this positive 3 to everything in the group. But the 8x has to be rewritten first. That's still part of the next work step. 3 times negative 2 is negative 6. Don't forget the x. 3 times 1 is 3. And now we're moving on to the right side. Negative 1/2 times negative 4 is positive 2x. Negative 1/2 times positive 10 is negative 5. Don't forget to write the plus 8 at the end. Now, before we can decide if we have one of these special solutions, we have to combine all the terms that we can on the left and right sides. Because right now, we don't have matching variable terms. But if I were to combine these two terms, I would get 2x, and I would rewrite the plus 3. On this side, I would combine these two terms, and I would get 2x plus 3. You see that? It's a perfect match. The variable terms match, the constant terms match. And when that happens, that's infinite solutions. So choose infinitely many solutions from the drop-down menu. Let's try this one more time. Again, distribute to clear parentheses first. Negative 2x, positive 4. Don't forget to rewrite anything else that's left. On the right side, leave the 6 alone, but distribute the minus 2. Combine like terms on the left, combine like terms on the right. So for us, the left side will be negative 2x plus 2, and the right side will be 6 and minus 4. That makes 2, and then minus 2x. Look carefully at your variable terms. Are they a perfect match? Yes. Now look carefully at your constants. They are also a perfect match. And when everything is the same, you have infinitely many solutions. Let's practice one more time. Let's see what we get. 3/2 times 6x is going to be 9x. 3/2 times minus 4 is going to be minus 6. Don't forget to bring down the plus 1. Now over here, we're going to get negative times negative is a positive 32x. A negative times a positive is negative 64. Combine like terms. These are like terms. These are like terms. So it looks like my new sentence will be 9x minus 5 equals 32x minus 62. This is definitely not a match. So we definitely have one solution. The question is, what is it? So I'm going to take that away, so I've got some space here. I'm going to subtract 9x, but I'm also going to plus 62 because I'm running out of space. So I'm trying to do 2 steps on the same line here. Make sure you have a cross out on the left and a cross out on the right. Okay, so 62 minus 5 is 57, and 32 minus 9 is 23. Divide both sides by 23, and get your wacky answer. So the fraction 57/23 is our one solution. So make sure that we type that in the answer box. All right, now we're going to move on to the last two sections. The last two sections look a little bit wordy, but they're really just looking for your main idea understanding. So they want this equation to have 0 or no solutions. They want this equation to have no solutions. The only way for that to happen is for it to have matching variables on both sides, but to have different constants. They have to have different constants. So we've got the matching variables, but we need different constants. So they're asking us, what could go in the h position? What number could go in this h position that will make sure that we have no solutions? And the answer is any number except -2. You could pick any number in the world that you want, but don't pick -2. So I'm going to pick 9. And the reason why I can do that is because you get 0 solutions when you have the same number for x, but you have different constants. So they're just asking you to show that you understand that main idea. Let's try one more. This equation will have infinitely many solutions. When h is equal to what? Well, for infinitely many solutions, you have to have matching variables, which we do, the same variables, but infinitely many solutions must have the same constant. So if this is a -4, h has to be a -4. So we're going to type that here in the box. It must be the same number. And that's because in order to have infinitely many solutions, you need the same number of x's and the same constants. Both need to be the same. One more time. This equation will have one solution. One solution can only happen if your coefficients, right, your variable terms, if this coefficient is different. That's the only way you're going to get one solution. The variables must be different. The number of x's on each side must be different. So this one has a -1/2. So this one can be any number you want, but not -1/2. So don't pick -1/2, but you can pick any other number you can think of. So I'm going to type in here the number 4. And that's because you get one solution when you have different number of x's. Now you see this constant here, -3, and this constant here, -8? It actually doesn't matter. It doesn't matter if they're the same or they're different. Because as soon as your x's are different, you've got one solution. So for this one, we're going to choose the last option. The constants can be the same, or the constants can be different. It doesn't matter. Let's try one more. All right, this one has one solution. One solution can only happen if these x numbers are different. The coefficient for x must be different. So I can pick any number in the universe, but I can't pick -3/2. So maybe I'll pick -5/17, right? Doesn't matter. Because as long as you have different number of x's, and the constants can be anything you want. So the last section of the homework is asking the same, except you have to do a little math before you can answer the question for H section here. Now for this one, the sentence will look a little bit more complicated, but just focus on what they're asking you to have. They're asking you to have 0 or no solutions. They're asking you to have no solutions. And the only time that can happen is if your x's are the same, but your constants are different, right? I can do this part already. The only way to have 0 solutions is for the x's to be the same, but the constants can be whatever they want. So before we distribute, let's just concentrate on what would happen here to my x. What would happen here to this x? So this one would be multiplied by -5. And if I need the same number of x's on both sides, then what does this number have to be to get this to turn into a -5x? And the answer is, it would need to also have a 5. But it's already negative, so I just need a 5. 5 times minus x is -5x. -5 times x is -5x. And my variable terms are matching. It doesn't matter what the rest of this distributing is. It doesn't matter. Because all we know is that we need our x's to match. So we need a 5 out front. Let's try this one more time. Let's concentrate on what they're asking for. They're asking for one solution. And that can only happen if our number of x's are different and the constants don't matter. You just need a different number of x's. So let's look carefully at how many x's we have on the right side. We have -9x on the right. So over here, I need anything that's not a -9. So if I pick the number 3, I would get -9. And I don't want that. So I can pick any number I want, but don't pick 3. So I'm just going to pick a random number. I'll pick 7. Submit your answer, and there you go. Good luck.